let's go ahead and start the next part of the video. So we've already solved logs, now we're going to solve exponentials. So if you're on page 18, you'll see that the standards say, write a function defined by an expression in different but equivalent forms to reveal and explain different properties of the function. So you're only going to do this with logs and exponentials. Use properties of exponents to interpret expressions of exponential functions, and again, just exponents and logs. So your learning target is that you're going to be able to solve an exponential function. All right. So at the bottom of the page, it says parts of an exponential function. The big number, which is b in this case, is going to be your base. That is always your base when it's an exponent, or when it's exponential form. The number that's raised, or the superscript, the one that is up higher, is always going to be your exponent. Okay? So to solve an exponential function, the bases have to be the exact same. So your bases have to be the exact same. You need to highlight that, mark it, whatever it is that you need to do so that you know that they have to be the exact same. You can't do anything, or you're going to have to fix it to where they're the same if it's not the same. So our bases have to be the exact same. That means they have to match. All right. So let's go ahead and go to the next page, page 19. All right. So solve the following for x, and you may need a calculator, so go ahead and get that ready to go. So pause the video if you need to, get you a calculator, and then that way we can get started on this. All right. So example 1, we have 5 to the x is equal to 5 cubed. Now this is my base. This is my base, this 5. And my exponents are the x and the 3. All right? Now if you read in the little box that's up here, it says if the bases are the same, drop them. So our bases are the same, so we're going to drop them. Just like we did when we were solving logs and there was a log on each side, we took and dropped those logs. And then we're going to set the exponents equal to each other. So we're going to take and set this x equal to this 3. And then we solve out. Well, there's nothing that we have to change. So x is equal to 3. All right, example 2. Look at our bases. We have 10 and 10, they're the same, so we can drop them. And we're going to be left with 2x is equal to 8. Now we need to solve out for x. So we will divide by 2. When we divide by 2, the 2's cancel, and we're left with x is equal to 8 divided by 2 is 4. All right, example 3. Look at those bases. We have 6. It's the same, so we're going to cancel it out. We have negative 2a is equal to 2 minus 3a. All right, on this one, I'm going to go ahead and move my 3a over because that way it'll just be easier, and I'm not having to move that 2 back and forth. So I'm going to add 3a to both sides. So plus 3a. When I do that, negative 2a plus 3a is a. There's nothing to go under that 2, so we're going to bring it down. And then negative 3a plus 3a cancels out. So my answer is 2. All right. So let's move on. All right, if you look at the bottom, this is powers that you need to know. I urge you to pause this video, take a calculator, figure these out, so that way you're used to pushing this into the calculator, and then check and see if they're correct, because I'm just going to go through here really quick and put the answers on there, okay? So 2 squared is 4, 2 cubed is 8, 2 to the 4th is 16, and 2 to the 5th is 32. Next we have 3. It's going to be 9, 27, 81, and 243. Okay? Next you have the 4th, so 16, 64, 256, and 1024. All right, next is our 5s. So 25, 125, 625, 3125. All right, now make sure you're looking at what you're raising these to, because those were 2 raised to a positive power. This next set is, it was 2, 3, 4, and 5 raised to a positive power. The next sets are going to be 2, 3, 4, and 5 raised to a negative power. So if you can remember, when we have a negative power, it gives us a fraction, because to make that exponent positive, we need to flip it. All right? So you're going to have 1/2, 1/4, 1/8, and 1/16. All right? And then for 3s, 1/3, 1/9, 1/27, and 1/81. Okay, go to the 4s. 1/4, 1/16, 1/64, and 1/256. All right, and then the 5s, 1/5, 1/25, 1/125, and then 1/625. All right, so that takes care of all of the whole numbers. Now we're going to work on the fractions. And again, just watch what it's being raised to, because you have positives and you have the negatives. So the first set is 1/2, 1/4, 1/8, and 1/16. And all this is, and I'll go ahead and show you, like for instance on this one, that is 1/2 times 1/2, and you would multiply straight across, so that's where the 1/4 comes from. Let's go down to the third, or 1/3. So 1/3, 1/9, 1/27, and 1/81. All right, to the 4th, 1/4, 1/16, 1/64, and 1/256. All right, and then one more set, and it's the negative. Remember, if it's a negative, we've got to flip it so it'll end up making that exponent positive. So these are going to look familiar to you. So 1/2 becomes 2, 1/2 to the -2 becomes 4, and then 1/2 to the -3 becomes 8. Because all that's happening is this, and I'm going to use this one because I have more room right here. To make this a +3, I'm going to have to flip this, so it's going to end up being 2/1 to the third because it's made it positive, or 2 to the 3rd power. And if we look back up at the first little box, 2 to the 3rd is 8. All right, to the thirds, we have 3, 9, 27. And then the 4, 16, 64. So that's something that you want to remember. Make sure you have this chart available to you over the next couple problems, because we're actually going to change some bases now. All right. So solve the following for x. All right. Now, if we look at these, this little box gives us our hint. If the bases are not the same, use the powers to know. Okay. So if they're not the same, that box that you just filled out, you're going to use that. So if you look back over to your boxes, where do you see the answer 9? The first time. And if you're looking straight down, you're going to get 3 squared. So we're going to replace that 9 with 3 squared. So 3x is equal to 3 squared. All right? Now, some of these you may be able to spot pretty quick. Some of these you may not be able to. But just know that 9 and 3 squared are the same thing. We just have to write it because we need to get our bases the same. And now they match. Once your bases match, we're going to do what we were doing just a minute ago. Cross them out and set our exponents equal to each other. And there we go. All right, number 5. Look to see which one matches the 27. And we're going to have 3 to the third. All right? Now, when we do that, we have 3 to the 2x minus 1 is equal to 3 to the third. Our bases are the same, so we can cancel that out. Then we're going to be left with 2x minus 1 is equal to 3. We're going to solve out for the x. So add 1 to both sides. That's going to cancel. We're left with 2x is equal to 4. Then divide by 2. And then x is equal to 2. All right, I encourage you to stop this video and try the next ones. If you need to, watch one more and then pause. But whenever you feel comfortable, I want you to pause the video and I want you to try these for yourself, okay? So I'm going to go ahead and go on to the next one. So I need to find where I have an exponent with a base of 4 because I need to make these match. So I need a 4 right here. But which one gives me 1/64th? When I look at that, I know if I'm going to make this be a whole number where this is a fraction, then I'm going to have a negative exponent. And that's just by knowing those rules that we cover back in Unit 1. So if I look, 4 to the negative 3 is what would give me 1/64. So I have 4, and x plus 1 is equal to 4 to the negative 3. Now my bases are the same, so I can cancel them out. So I have x plus 1 is equal to negative 3. And then I'm going to solve out for x. So minus 1 on both sides. That leaves me with x is equal to negative 4. And you should have that answer. If you don't, look back over your work and see where it could have messed up. All right. Number 7. All right, so we have a base of 1/2. So we're going to want this to end up being 1/2. Okay? Well, we know this is a whole number, so in order to flip it to make a fraction, we're going to have a negative exponent. Okay, just like we did for the last one that we just did. So a negative exponent. All right? So if you look back in that chart, I'm going to write this so you can kind of see. But if you look back in that chart, you know that this can be raised to the negative 4. This can be raised to the negative 4. And then that's going to cause this to give you 16. Okay? So now, we have 1/2 to the x is equal to 1/2 to the negative 4. Now my base is 1/2, and it matches on both of them, so I can cross that out. I'm going to be left with x is equal to negative 4. So you're going to have to keep up with this chart, try to memorize it. If you can't memorize it, then you can take and write it down somewhere just so that you have it. All right? Number 8, there's 2 ways of doing this. I can make my bases 4, or I can make my bases 1/2. It just depends on which one you like to work with. Okay? Either way, you're going to get the same answer, and I'll show you. So if I make my bases 4, I'm going to have 4 to the x is equal to, so to get 1/2 to be 4, we're going to have to raise it to the power of negative 2. All right, but don't forget we have this little exponent out here. So we're going to take and put those together. And in order to do that, we're going to multiply those. So the first exponent that was with it was the x minus 3. And we changed it to a negative 2 to cause us to have a base of 4. All right, so in doing that, our bases are the same. And we have x is equal to x minus 3 times negative 2. And then just multiply this negative 2 out, distribute it to both of them. We're going to get x is equal to negative 2x plus 6. And we're going to solve out for x. So add 2x to both sides. That's going to give us 3x is equal to 6. And then divide by 3. When we divide by 3, we get x is equal to 2. All right? Now, I'm going to show you the other way as well. Okay? And you should get the same answer when you do it the other way. All right. So we have 4x, and we're wanting to change the 4x to a 1/2. So when we want to change this to a 1/2, look back in your chart and look and see where 1/2 is equal to 4. Or sorry, let's look at 4 and see where 4 is equal to 1/2. And it is going to be, let's see, we can flip it. No, sorry, you're not going to be able to change that to a 1/2 unless you're looking. Yeah, you will. Negative 2. So negative 2 is the one that's going to give you a 4. All right. So we have 1/2 to the negative 2, and it's equal to 1/2 x minus 3. All right. Then you're just going to take and solve out such your bases equal to each other, and then you're going to be able to solve that out. All right. So number 9, and I'm going to erase this. So that way I have some room to work and it doesn't go together, but you can rewind and pause if you need to. That is fine. I'm going to start with this one right here. So that way we know. All right. So if we look at this, we have a way of doing this. 2 different ways. All right. So we can look and see where 1/3 is going to be equal to 9. So we can change this to a 1/3. If we change that to a 1/3, then it's going to be negative 2 is the exponent that does that. And then we have to keep the exponent that was there. All right, and then 1/3 x plus 2, and it's equal to that. All right, so I have the same base. I'm going to cancel them out. So I have x plus 2 is equal to negative 2, 2x plus 1. Sorry, 2x plus 3. All right, I'm going to take and distribute this negative 2 to everything that's in parentheses. Okay? So I have x plus 2 on this side, and then negative 4x minus 6. All right. Now I'm going to add 4x to both sides. So go ahead and combine like terms. So add 4x. 4x plus x is 5x. Bring down that 2. Negative 4x plus 4x is 0, and then is equal to negative 6. So just bring it down. Now I'm going to subtract 2 from both sides. So 5x. 2 minus 2 is 0. Is equal to negative 6 minus 2 negative 8. All right, and then the last step that I'm going to do is I'm going to divide by 5. When I divide by 5, I have x is equal to negative 8/5, and you can put that negative anywhere as long as it's on this fraction. So you could have a negative 8/5, you could have 8 over 5, and the negative be out front, or you can put it with that 5. Any way is fine. Okay? Now, let's flip over to the back. Page 21. All right, sometimes both bases need to be changed. So in this case, we're going to change both bases. All right? So you're going to have to be able to look on that chart where the powers to know and find where you see these two bases in the same box. So both bases need changed. Okay? So if I'm looking back over at my box and we're looking for the base of 8 and we're looking for the base of 16 to be in the same box. So if I'm looking back over here, which box, sorry, I went too far. Which box do I see 8 and 16 in? Well, if I'm looking, I see an 8 here and I see a 16 here. So I'm going to use the base of 2 for both of those. So for the 8, it's going to be a base base of 2 raised to the third. And then for 16, base of 2 raised to the fourth. Okay? So this one's going to end up being 2 to the third. We're going to keep the 2x minus 4 is equal to 2 to the fourth and keep the 2x plus 4. All right. My bases are the same. So I'm going to cancel those out. And I have 3 times 2x minus 4 is equal to 4, 2x plus 4. All right, distribute what you have on the outside to everything that's on the inside. Okay? So 6x minus 12 is equal to 8x plus 16. Now combine like terms. So subtract 6x from both sides. That leaves me with a negative 12. And that's going to be equal to 2x plus 16. Now I'm going to subtract 16 from both sides. I'm going to put my answer right here. So negative 12 minus 16 is a negative 28. And that is going to be equal to 2x. And then I'm going to divide by 2. And then negative 28 divided by 2 is a negative 14. So x is equal to negative 14. All right. Number 11. If you want to pause these and try these next two, that's fine. See if you can find the exponent that goes with, or the base that goes with them. And then check and see if you got it right by clicking back on it, push and play, and starting it over again. All right, so this one is going to change to 5 raised to the third, and then 5 squared. All right, so I've already taken and changed it to where I have the same base, so I can cancel that out. Now I'm going to have 3 times x is equal to 2 times x plus 1. This is going to give me 3x is equal to 2x plus 2. Combine like terms, so I'm just going to move that 2x over. 3x minus 2x is x. 2 minus 2 is 0, and it's going to leave me with 2. All right, number 12. This one is going to be 3 squared. And then I'm going to have 3 cubed. All right. Now my bases are the same. So it's going to cancel them out. I'm left with 2 times x is equal to 3 times 2x plus 8. Okay? So we have 2x is equal to 6x plus 24. All All right, and then combine the like terms. So I'm going to subtract 6x from both sides. So we have negative 4x is equal to 24. And then I'm going to divide by negative 4. And x is equal to a negative 6. All right. So we have 2 more. Or 3 more, sorry. And then we will be done with solving. All right, so for number 13, same concept. See if you can find the same bases and all. If you want to pause and try these, go ahead. So this one will be 3 raised to the third, and then 3 to the fourth. Got the same base. So 3 and then x plus 2 is equal to 4. So I have 3x plus 6 is equal to 4. I'm going to subtract 6 from both sides. That's going to leave me with 3x is equal to negative 2. Then I'm going to divide by 3. X is equal to negative 2/3. Okay? All right, number 14. I'm going to get 2 to the third. And then the other one, or 1 over 16, is going to be 2 to the negative 4. 2 to the negative 4, and we have x minus 1. It was still there. All right, my bases are the same. So there we go. We have 3, and then it's 2x minus 3 is equal to negative 4, x minus 1. All right, distribute that. 6x minus 9 is equal to negative 4x plus 4. Now, combine your like terms. So plus 4x on both sides. It's going to give me 10x minus 9 is equal to 4. I'll add 9 to both sides. That gives me 10x is equal to 13. I'm going to divide by 10. X is equal to 13/10. All right, one more. All right, so the first one. I'm going to do this one as a fraction just because I've done the other ones as a whole number, so I'm going to just do this one as a fraction. So if I take this to 1/5, it's going to be squared. Then I'll have the 2x is equal to 1/5 to the third times negative 1. All right, so same concept. It's just that I kept it as a fraction. Same base. So I have 2 times 2x is equal to 3 times negative 1. All right, so I have 4x when I distribute is equal to negative 3. All right, and then I'm just going to take and divide by 4. I'm going to get x is equal to negative 3/4. All right, so that is the last of the solving. We solved exponentials and we solved logs. We're going to practice these together. You're going to have a quiz over all of the left, right, left, expanding and condensing, and over the solving. So just practice these. If you want more practice, it will be available to you.